Morning students. In this class, we are going to discuss about transmission media. The transmission media, there are two types are there. One is guided media, another one is unguided media. So the guided media example twisted pair, coaxial cable and optical fiber. In this class, we are going to discuss about the guided media. Under the guided media, I explain only the twisted pair. The next video, we will see the coaxial cable and optical fiber. Okay, so in this video, the guided media twisted pair. First, what is transmission media? So when you consider the network, when you send and receive the message between sender and receiver, the transmission medium is very important. So normally in the network, the physical layer is responsible for connecting the transmission media. Okay, so the transmission media is a pathway that carries the information from sender to receiver. We can use the different types of cables or waves to transmit the data. The data is transmitted normally through the electrical or electromagnetic signals. So when you consider the transmission media, the characteristics and quality is determined by medium and signal. So the medium, when you consider the medium characteristic, there are two types of medium, guided media and unguided medium. What is guided medium means? There is a wire connection between the sender and receiver. So there is a dedicated path is there between the sender and receiver. So there is a wired, that is a guided medium. Unguided medium means there is a wireless. There is no dedicated link between sender and receiver. Then for guided medium, the medium is more important. For unguided medium, the bandwidth produced by the antenna is more important. So what are the design factors of transmission media? There is bandwidth, transmission impairment, interference, number of receivers. In the bandwidth, the higher bandwidth gives higher data rate. Transmission impairment. Already we had discussed about there are three types of transmission impairments. The transmission media use the transmission impairment attenuation. Then interference issue, especially in case of unguided media. Then number of receivers, so there may be unicast or multicast. Unicast, there is one sender and one receiver. One sender can sending the data, one receiver can receive the data. But when you consider the multicast, multiple receivers can introduce more errors. There are multiple receivers are there. When sender can sending the data, the multiple receiver can receive the data. Then types of transmission media. Mainly the transmission media, there are two types are there. One is guided media, another one is unguided media. Under the guided media, what are the examples for guided medias are twisted pair cable, coaxial cable, optical fiber cable. Under the unguided media, radio waves, microwaves and infrared waves. The transmission media question is very important. Okay, guided media, either the university question paper, they may be asked guided media or unguided media? Definitely, there is one question is there. So the transmission medium is very important question. Either guided media or unguided media. First, guided media. In this guided media, the signal energy is enclosed and guided within a solid medium. The guided media is used either for point-to-point link or a shared link with various connections. In the guided media, there is between sender and receiver, there is one dedicated link is there. So the dedicated path can be established using the wires. So between the sender and receiver, there is one dedicated link. That dedicated link may be any wires. When you consider the guided media, the signal energy propagates through a wireless medium. Here there is no dedicated path between the sender and receiver because it's a wireless communication, wireless medium. The wireless media is used for radio broadcasting in all directions. Microwave links are chosen for long distance broadcasting transmission, unguided media. The interference is also a problem in guided, unguided media. Overlapping frequency bands from competing signals can alter or eliminate a signal. Okay, these are the transmission media. What are the overview of transmission media? Then what are the design factors? What are the types of transmission media? Guided media and unguided media. Next, we will see about the guided transmission media. So what are the types of guided transmission media? Twisted pair. That medium may be using the twisted pair, coaxial cable or an optical fiber. First, the transmission characteristics of guided media. When you consider the frequency range for the twisted pair 0 to 3.5 kHz. The twisted pair multi-pair cables 0 to 1 MHz. When you consider the coaxial cable transmission media, the frequency range is 0 to 500 MHz. Optical fiber 186 to 370 THz. Okay, so there's a difference between the twisted pair, coaxial cable and optical fiber based on the frequency range, attenuation, delay, repeater, spacing. Okay, this is the table. The transmission characteristics of these three guided media. What are they? Twisted pair, coaxial cable and optical fiber. First, we will see about twisted pair. This question is very important. Twisted pair, coaxial cable, optical fiber. So first, in this video, I am going to explain about the twisted pair. The twisted pair cable is the most common form of wiring in data communication application. This medium is very common form of wiring in data communication application. So one of the earliest guided transmission media is the twisted pair cables. Here, a twisted pair cable comprises of two separate insulated copper wires which are twisted together and run in parallel. The copper wires are typically 1 millimeter in diameter. One of the wires is used to transmit data and the other is the ground references. The twisted pair cabling is the type of wiring in which two conductors of a single circuit are twisted together for the purpose of improving electromagnetic compatibility. Okay. So this is the architecture of twisted pair. You see the block diagram of twisted pair. Two insulated copper wires are twisted. So the name is twisted pair. So one twist, that is a twist length. Separately insulated. Twisted. Two copper wires are twisted together. So often it is bundled with into cables, usually installed in building during construction. So normally when you install the building, the twisted pair cable is used. Okay. Then issues are the interference due to unwanted electrical coupling of two copper, interference due to unwanted electrical coupling between the neighboring twisted pairs. Then what are the applications where we can use the twisted pair? The twisted pair is most commonly used medium. Okay. It is used in the telephone network within the building. The local area networks also we can use the twisted pair. When we use the twisted pair in the local area network, so the rate is 10 megabits per second or 100 megabits per second. Then what are the advantages and disadvantages of twisted pair? So when you consider the advantage, it is very less expensive, easy to work with. Disadvantages: low data rate. It covers only the short range. Okay. Then next, what are the characteristics of twisted pair? When you consider the analog transmission, the amplifiers every 5 kilometer to 6 kilometer. So when you use the twisted pair cable, for every 5 kilometer to 6 kilometer, we must use the amplifiers for the analog transmission. The digital transmission use either analog or digital signals. The repeater every 2 kilometer or 3 kilometer. So analog amplifier is used for the digital transmission. The repeater is used for every 2 kilometer or 3 kilometers. Then the twisted pair is limited in distance, bandwidth and data rate. So there are two types of twisted pairs. One is unshielded twisted pair, another one shielded twisted pair. Normally the twisted pair we can denote TP. Okay, then unshielded twisted pair UTP. Shielded twisted pair STP. So unshielded twisted pair, there is a ordinary telephone wire. It's a less expensive, weak immunity against noise and interference. When you consider the shielded twisted pair, an extra metallic sheet on each pair. So when you twisted pair means two insulated copper wires are twisted. So here in the shielded twisted pair, one shield is there. The twisted pair is shielded. That's it. The name is shielded twisted pair. An extra metallic sheet on each pair. Next, relatively more expensive. Provide better performance than UTP. So when you consider the performance of the STP, increased data rate and increased bandwidth. Okay. So now what number of categories are there in the unshielded twisted pair? What are the categories are? Category 3, 4, 5, 6, 7. Under the 5, there is one more, that is 5E for the enhanced twisted pair. For category 3 up to the 16 megahertz, the voice grade found in most offices, twisted length is 7.5 centimeter to 10 centimeter. When you consider the category 4, that is limited up to 20 megahertz. Then category 5E, 5E for the enhanced, then category 6 and category 7. So the different categories are there for the unshielded twisted pair. Okay, thank you students.